Right, this is section 3.1, quadratic functions and models. Let's look at a definition first. Let a, b, and c be constants with a not equal to 0. A function represented by f of x equals ax squared plus bx plus c is a quadratic function. Notice the highest exponent is square, or a 2. This is called the general form for a quadratic function. So if it's written this way, it's in general form. Identify, number 1, an example. Identify whether the function is linear, quadratic, or neither. Let's do a couple of these, and let's do a and b, and then we'll do c and d in class. Okay, so a and b, is that quadratic? Yes, it is, because it is in that form. A is -1, by the way. Let's zoom in a little bit. All right, so a is -1, b is 2, and c is 3. It's that one. Letter b, so this one is a yes. Linear, quadratic. So this one's quadratic, I'm sorry. Not a yes, quadratic. Letter b, f of x equals the square root of all that. No, that is not written in that form. Cannot be written in that form either. And it is not linear. It's not f of x equals mx plus b. So it is neither. I'm sorry, I'm saying yes or no, but it's this one is neither. All right. So the other ones, when we're in class, we'll classify them as linear, quadratic, or neither for those two. All right, let's go on to the next part. Vertex form. So vertex form is of the form f of x equals a times x minus h squared plus k, where the vertex is hk and a is not 0. So this tells us that we can write a quadratic function in this form. That one, remember, was a general form. This one is the vertex form, is called the vertex form. And it actually shows us the vertex, hk. Vertex, by the way, is where it turns. That's the vertex, there's the vertex, there's the vertex, right? Where it turns from going up to going down, or from going down to going up. All right, let's take a look at a couple of things. So first, note the effect of a on f of x equals ax squared in the following graphs. So for the first one, notice a is 1. For the second one, notice a is 2. And for the third one, a is -0.5. So what does that do? Well, when a is 1, there's certain reference points that we can find. From the vertex, when a is 1, if we go 1 to the right or 1 to the left and 1 up, there's a point on the graph. Right? We run into the parabola. If we go 2 to the right and 4 up, or 2 to the left and 4 up, there's another point on the graph. And I also know that if we go 3 to the right and 9 up, we'll hit another point on the graph, or 3 to the left and 9 up. Now, how do I know that? Well, because when I square 3, I get 9. Notice when I square 2, I get 4. When I square 1, I get 1. That's how I know. Okay? All right, so that's when the coefficient here is 1, when a equals 1. What happens when a equals 2? Well, each of those, remember I said 3, 9, the y value gets doubled. Okay, so instead of going 3, 9, we're going to go 3, 18 if y equals 2, if a equals 2, I'm sorry. So we go 3, 19. Instead of 2, 4, if we double the y value, it'd be 2, 8. So notice if I go 2 to the right and 8 up, there's, from the vertex, by the way, it's right, 2 to the right and 8 up, or 2 to the left and 8 up, there's a point on the parabola. Same thing with 1, right? So usually when it's 1, I would go 1 to the right or 1 to the left and 1 up. So instead of 1 up, it's going to go 2 up. Notice, really, your vertical distances are just being multiplied by that a. And in fact, that's actually what happens over here. Okay? Now notice, if it was 1, I would go from the vertex 1 over to the left or right and 1 up. But if I multiply that 1 up times -0.5, it's 1 down, half down, right? Half down. And instead of going 2 over to the left or right and 4 up, it's going to be 2 over to the left or right and only 2 up. I'm sorry, 2 down, because it's negative. 2 down. Okay, so it's just turned upside down. And so 3, 9 is going to go 3, -4.5. And 4, 16 is going to be instead 4, -8. And notice, yes, indeed, there's points right there. Okay, so the negative will flip it upside down, right? And then the magnitude of that will multiply your vertical moves by that same number. Okay, let's go on to number 2 for f of x equals 3 times x plus 1 squared minus 8. And let's do a couple of these. Let's do A and C, and then I'm going to let you do this, but I'll give you a hint as to how to do it. Okay, so let's start with A. A says give the vertex. So remember, this is f of x equals x minus k squared, x minus h squared, I'm sorry, plus k, and the vertex is hk. The vertex is hk. So x minus h, if I look at x plus 1, well, I want to think of it as minus x minus negative 1. So this is going to be 3 times x minus negative 1 plus negative 8. So there's my vertex, right? It's negative 1, negative 8. All right, notice it's f of x equals. I just don't need to write all that because I'm only looking at my h and my k. All right, let's try C. Find the minimum y value. Now, what does that mean? Well, notice that your parabola, that's A, by the way, right? That A is the A that would go right there. So that's our A. Our leading coefficient is a 3. That means our parabola is going up that way, right? It's and that means that the vertex is down at the bottom. So the minimum y value would be the y value down at the bottom, which would be at the vertex, and it's just the y value. So that would be negative 8. Okay? Now, how do we get to the general form? Remember, the general form is this one. And we're here. So what we need to do is distribute, do the x plus 1 squared, then multiply by 3, and then combine with the negative 8. And I'll let you do that. We'll do it in class also. All right, let's go on to number 3. Use the graph of a quadratic function to write its formula as f of x equals a times x minus h squared plus k. So first you start with what you can see right off the bat. Remember, h and k are the coordinates of the vertex. That's right there. This is negative 2, negative 4. So I'm just going to plug those in and see what I have. So I have then f of x equals, I don't know what a is, times x minus negative 2, which is plus 2 squared, plus negative 4, that would be minus 4. Okay? So notice all I need to do is find a. Okay? All right, so I'm going to stop right there and give you a chance to think about, how do I get a? Well, remember I said over here that a, right, the effect of a on the parabola, just multiplies your vertical distances from this pattern over here, right? So 1 to the right or left and 1 up. Yeah? So if this was a 2, it'd be 1 to the right or left and 2 up from the vertex, right? Yeah? So that would be a 2. You would have to be able to go 1 to the right or left and 2 up, and that's not happening, right? Is it a 1? Well, whatever your vertical distances are being multiplied by, right? Whatever they're being multiplied by. They might be getting multiplied by 2, or by half, or by 1/3, or by 1/4. Whatever it is you can find, right? That's one way to do it. Another way to do it is to pick a point on the graph. Okay, so what points are there? Well, there's several that we can use. There's this one up here. I'm going to use this one up here just because you have positive numbers. Okay, so you have the point 2, 4 on the graph. Right? So this tells us that when x equals 2, f of x equals 4, or y equals 4, right? X equals 2, y equals 4, or you can think x equals 2, f of x equals 4. And what I'm going to do is, and I'm not going to do it here now, I'm going to let you guys do it in class. You can actually plug those values in here, right? You have an x and an f of x. You can plug in your x and your f of x and see what you can do with that. Okay? And we'll finish that in class. Let's go on to vertex form. Oops, vertex formula, I'm sorry. So the vertex formula tells us how to find the vertex when we have the general form directly, how to find the vertex. Okay, so the vertex is found in the following way. For the x value, you find it by using the formula that h, remember hk? H is negative b over 2a, and then k is f of that, okay, or the y value. All right, let's do a couple of these. Okay, so So let f of x equals that, negative 5x squared minus 40x minus 8, give the vertex. So then h is negative b over 2a. That'll be negative of whatever b is over 2 times whatever a is. I'm going to plug in those numbers. B is negative 40. A is negative 5. Notice there's 3 negatives, so my answer is negative. And then 40 over 10 is 4. Negative 4, right? Negative 4. Okay. And then K will be f of that. Okay, so K is f of negative 4. Let's put it in red so we know highlighting that x value equals negative 5 times negative 4 squared minus 40 times negative 4 minus 8. Plug those in there. Alright, so and then we're just going to work it out. This is negative 5 times 16. Minus 40 times minus 4 is plus 160 minus 8. This is negative 80 plus 160 minus 8. This is 80 minus 8, and that's 72. So my vertex is negative 4, h, comma, 72. Negative 4, comma, 72. That's the vertex. Way up there, right? Okay. And then find the minimum y. You know what? I'm going to let you guys think about B and C. And again, we'll do those in class. All right. I'm going to pause this first part here, and we'll pick up on the next part, the next video.